Okay, so what we're going to look at is we're going to go back to looking at limits, and L'Hopital's rule has something to do with limits. And we've seen this kind of before. You've seen things that look like 0 over 0 and infinity over infinity. And you've learned how to do these things in a different way. L'Hopital's rule is a little bit different way to approach this. If you look at this example, I'll see if you guys remember this or not. Now we're going to infinity, okay? So if you're going to infinity, you're looking to see if you have a horizontal asymptote. Okay, why is the answer to that problem 2/3? Let me ask you that.
Because the top and bottom variables are equal.
Right, okay, the degree of the top and the degree of the bottom are the same, right? So we said 2/3 is the horizontal asymptote. So that thing is going to level off at 2/3. L'Hopital's rule is going to give us a different way to do that that's like fast and efficient. Now on this one, what happens on this one is if you plug in x, you have 0 over 0, and then you want to factor that then. So I do want you guys to write something on this then, okay? So first of all, if you plug 2 in, you would have 2 squared minus 4 over 2 minus 2. So that's 4 minus 4 over 2 minus 2. That's 0 over 0. Now 0 over 0 is what we call an indeterminate form. It's not undefined. I mean, it is undefined because you're dividing by 0. But 0 over 0 is kind of indeterminate when we're talking about limits. So the way that you guys learned how to do this, let me ask you, what can you do to the numerator? Factor. You can factor it, exactly. So if you factor it, what you would have is you would have the limit as x approaches 2. And then this would factor as x plus 2, x minus 2, all over x minus 2. Okay, that crosses out. And what that really means, let's see if you guys remember this or not. If that crosses out, that is not a vertical asymptote. What is it? It's a hole. So that means the limit exists because you're connecting, at that hole like that. So then what you would do is just reevaluate the limit. So now plug in the 2 and get 2 plus 2 is equal to 4. Okay, that's what you learned back towards the beginning of the semester with limits. And if it's a 0 over 0 form, typically you did some algebra, reevaluated, and you got an answer. That canceled out. That's why there's a hole, which is why the limit exists. Okay, so what L'Hopital's rule is it's real simple. What you do is if you have, and we're only going to look at 2 things in this class, and this is real important. First of all, you got to make sure you have a 0 over 0 form, or you got to make sure you have an infinity over infinity form like that. If you do, then what L'Hopital's rule says is just do the derivative of the top, derivative of bottom, and then reevaluate the limit. Okay, it's real simple when you do that, and sometimes you have to do the derivative more than once. So it's a real simple thing to do, okay? But the thing is, you got to make sure that you have one of these 2 forms, okay? And those are the only 2 forms we're going to look at. There's L'Hopital, looks like a rock star, doesn't he, with that big curly perm, and I think that's a wig.
I wonder where he gets his haircut at.
Yeah, it's back in those days, wigs and stuff were really in. So this is kind of the development of calculus. This is the early development of calculus, and a lot of people were beginning to work on that. Okay, so let's do the problems that I just did, but this time we're going to do L'Hopital's rule, and it's real simple. So what you would want to do, again, if you look at this first example, if you replaced the x with infinity, what you'd have is 2 times infinity minus 3, and then you'd have 3 times infinity plus 1. Well, for all practical purposes, the numerator is infinite, right? Because you're doubling infinity and subtracting 3, that still means it's infinite, right? The denominator is also infinite, okay? Okay, just goes to infinity because you're multiplying the numbers by infinity. So that would give a form, and then now you know you can use L'Hopital's rule. So here's what you do. What you do is you just do the limit as x goes to infinity, and then you do the derivative of the top. Now you can do this in your head. And then you do the derivative of the bottom. And then you reevaluate your limit. Okay, like that. Okay, so what you're going to have now is the limit as x goes to infinity, what's the derivative of the numerator? And how about the denominator? 3. Okay, so you're doing the limit of 2/3. Okay, do you remember what a limit of just a constant is? Itself, okay, because if you graphed y equals 2/3, it's just a horizontal line. So that's 2/3, so that's your answer. Okay, that's it. You don't have to know anything about asymptotes to do that. It'll just do the derivative by L'Hopital's rule and it'll work out. Okay, all right, let's look at the next one. So again, let's plug this in again, just kind of to verify. I already did this on the previous page, but it's important before you go to L'Hopital's rule that you make sure that you either have infinity over infinity or 0 over 0. So if you plug 2 in, you have 2 squared minus 4 over 2 minus 2. That's easy enough to do in your head. Yeah, you have that form. Okay? All right, so here's what we want to do then. This is usually the way I like students to do this problem is this way. Just go ahead and write the problem down. And since we know it's 0 over 0, and you've got to, show that on your paper when you're doing homework and stuff, verify it's 0 over 0, okay? Now what I like you to do is put an equal sign. Then I usually have you put LH for L'Hopital's rule, and then you can do the derivative of the top and bottom. Okay, and then the derivatives we do are probably pretty simple. Okay, what's the derivative of the numerator? Careful, 2x, okay, and what's the derivative of the denominator? 1. Okay, so we do that, okay? So now what you can do is just plug in, all right? So if you do that, you're just going to plug that in, and you'll get 2 times 2, so it's equal to 4. Okay, that's easier than factoring. I mean, factoring's not very hard on this problem, but if your derivatives are simple, then you can do L'Hopital's rule real easily, see? Okay, all right? So does that make sense, what I'm doing? Okay, all right. Okay, let's do a few more of these exercises, and I'll give you a chance to do a few of these. Okay, let me go through A and B, and then I'll let you guys do, no, let me do A and C, then I'll let you do B and D. Okay, that way we're kind of doing one of each here. Okay, so first of all, on A, okay, if we plug in, if you just do this, you can also kind of this infinity thing, reason this out in your head. So you have really this, okay? Now, is the numerator infinite? Yeah, is the denominator infinite? Yeah, I'm just making infinity bigger by plugging that in. So we would say the form is infinity over infinity. So make sure you have that. Okay, now what we want to do, let's just write equals and then the LH. And then you're going to be able to do, most of the time, you just do these derivatives in your head. Okay, so what's the derivative of the numerator? 6x, denominator, 3x squared. Good. Okay, so now we have this. We have 6x over 3x to the second. Okay, like that. Now you can go ahead and you can simplify if you want to. Like for instance, I would just cross that out and make that a 2. And there's different ways to do that. So let's go ahead and write, we have limit x goes to infinity of 2x over x squared. Okay, we can do that. Now the thing on this is, if you evaluated it at infinity now, what would happen is you would have 2 times infinity over infinity squared. Is that still infinity over infinity? Yeah, so you can do L'Hopital's a second time. So you can do the L'Hopital's rule more than once. So if I do this, let's see where this leads us. Okay, what's the derivative of 2x? 2, and the derivative of x squared? 2x. So now what you would have is derivative of 2x is 2, derivative of bottom is 2x. Now you can cross the 2's out, and that would leave you the limit as x goes to infinity of 1 over x. Okay? Now, if you plug infinity in now, you have 1 over infinity. What is that? If you take 1 divided by a super big number, where does it go? If you ever forget, play with your calculator. If you take 1 divided by something big, it's going to get close to 0. Okay, we've talked about that. It's been a while. So notice if I did something like this, 1 divided by, that's a pretty big number. Okay, look what happens. It's in scientific notation. It's a tiny number. Okay, so anytime that you have a number, and any number, the numerator can be any number. It doesn't matter how big it is. But if it's a finite number and you divide it by infinity, you're going to go to 0. So the answer to that problem is 0.
So you can do it more than once. You keep doing it?
Yes, you can keep doing it as long as you have that form. And what happened at the very end, I didn't have that form anymore. I had 1 over infinity, so I can reason out the answer. Now, I taught you a lot easier way to do this earlier in the semester. What happens if the degree of the top is less than the degree of the bottom?
0.
We said 0. Okay, you can still do it that way, but L'Hopital's rule definitely works if you do that then. Okay? All right? Yes?
For the first time you did the rule, when we had 6x over 3x squared, could you take out a 3x from the top and the bottom, and then you get 2 over?
Yeah, you could do that too.
Okay.
There's more than one way to do that. Once you got that first derivative, you would actually, if you simplified it,
You get 2 over
you would
x.
make it all the way down there anyway. Or yeah, you'd have 2 over x, right?
Yeah.
So, and it still works, still gets the same thing.
Okay.
Okay. All right, I'm going to go to C, and let's do that, and I'll let you do a couple of these. Okay. So again, find out what form you are. So I'm going to plug 0 in. So we have e to the 4 times 0 minus 1 all over 0. So that's e to the 0 minus 1 over 0. Okay, what's e to the 0?
1.
1. Okay, so you've got 1 minus 1 over 0, so you have a 0 over 0 form limit like that. Okay, so that means L'Hopital's rule applies to this then. Okay? Okay, so what we're going to do is we're going to do the derivative of the top and the bottom. Okay, and then see if we need to only do it once or twice. We'll kind of find out. Okay, what is the derivative of e to the 4x? E to the 4x, but something else, times 4. Okay, you got the chain rule. All right, so anytime you're doing a derivative of an exponential, it is itself, but the derivative of that exponent, the derivative of 4x is 4. So it's 4e to the 4x. That's chain rule. Okay, you know derivative of e to the x is e to the x, but if it's e to the f of x, it's the same, but then you got to multiply by the derivative of the exponent. Derivative of 1 is 0, and then the derivative of the bottom, x, is 1. So now we have that. Okay, so you got to do your derivatives the right way. Okay, now if I finish this, I'm going to have the limit as x goes to 0, and it looks like this is just 4e to the 4x, like that. Okay, you don't have to put that over 1. So what you do is just plug that 0 in and evaluate and see what you get. So this is 4e to the 4 times 0. So that's 4e to the 0. What's the answer? 4. 4 times 1. E to the 0 is 1. So you would get 4 as an answer to the problem. That's the value of that limit. Okay. If you graphed that on your calculator, and you can always do that to kind of help you make sense of the problem, you would find that around 0 that the limit would be approaching 4. Okay. Does that make sense? Okay, you got to have that derivative down. I can tell with, beginning to work on these tests, there's some problems with some of these type of derivatives with the chain rule. So just real quick, if you had something like the derivative of e to the x squared, here's what you do. It's itself, but what else? 2x, okay, the derivative of the exponent. Okay, it's real easy to do exponentials, but you got to remember that derivative of the exponent. That's how the chain rule works. Okay, go ahead and I'll let you work out B and D. That'll give you, you'll have a 0 over 0 and an infinity over infinity limit. So go ahead and do those. I'll pause this for a minute and see if you're okay with this. So this problem B, okay, first thing you do is plug in the 10, it's 0 over 0. Everybody understand that? And you've got to do that before you do L'Hopital's rule. Okay, if I do the derivative of the top, you should have got 2x minus 5. Derivative of the bottom is 1. So now you're just doing the limit of 2x minus 5. So now you're ready to plug in the 10. So you'd have 2 times 10 minus 5. 20 minus 5 is 15. Okay? And what would happen on that one is, as you're approaching 10, you would end up having a y value of 15. Okay? Does that make sense to everybody? Okay? All right? And see, the nice thing about that one is you don't have to worry about factoring. And sometimes, you have things that don't factor. Okay? So L'Hopital's rule makes that a little simpler. Okay, what I did on part D is, first of all, this is infinity over infinity. The numerator is getting infinitely big, so is the denominator. So the derivative of the top, you should have got 4x to the third. Derivative of bottom, you should have got 2x. And then what I did is I went ahead. I mean, you could do L'Hopital's rule again. There's more than one way to do this problem. I went ahead and just simplified. So the 4 over 2 is 2. X to the third over x to the first is x squared. Okay? Now, if you plug that in, if you plug an infinity in, it's just getting infinitely big. Okay? And we're going to look at this a little bit today, but notice in your original problem, the degree of the top, this is a good note to write here, the degree of the top is bigger than the degree of the bottom. And anytime that happens, you don't have a horizontal asymptote. Usually it's going to just turn up and go to infinity or negative infinity. That's another way to know that. And that degree is bigger. So if you graph that on the calculator, you would see that happening. Okay. I'm going to put this in the calculator because I want to show something to you. And why don't you go ahead and do this on your calculator with me? When you put a rational function in, be sure you put the numerator in parentheses, like I'm doing here, and then be sure you close the parentheses, and then divide by, and then the denominator is x squared plus 4. We'll just kind of start that off in a standard window. So be sure that when you're doing rational functions, that even if you're in doubt, there's times when you can leave parentheses off, but it's a good idea to just always have that on there. Now let's go zoom 6 to take us to a standard window, and it kind of looks like a parabola, doesn't it? Okay, there's something that goes on this. So the idea is you can tell as you're going out to infinity, the graph's just turning up and going to infinity anyway. Okay, so the graphing calculator should help you to get a pretty good, clear understanding of what's going on your limits. Okay? All right, let's go to the next page. And let's do a couple of more of these. And then I'm going to do the ones on this page, and then I'll let you do a few more, and then that'll be all we're going to do in this section. Okay, on A, let's go ahead and plug 0 in. So we have e to the 0 minus 0 minus 1 over 0 squared. Okay, remember you want to verify that it's the right form. E to the 0 is 1. Okay, so that is a 0 over 0 limit then. Okay, so that means we can go ahead and do L'Hopital's rule. Okay, all right, so what we're going to do on this, I'm just going to write this like this. Equals, anytime you do L'Hopital's rule, do that LH. That helps me know that, okay, you're doing L'Hopital's rule. You still have a limit when you do that, but let's do the derivative. So tell me what the derivative of the numerator is. E to the x minus 1. Good. Okay, so that's e to the x minus 1. Tell me what the derivative of the bottom is. 2x. Okay, now what will happen in here is if you evaluate your limit again right now, notice what we have is e to the 0 minus 1 over 2 times 0. What form is that? It's still 0 over 0, right? Okay. A lot of times you just kind of do that in your head, but that is 0 over 0 again, so that means you can do L'Hopital's rule again if you need to. Okay, so we do it the second time. Okay, and then we'll see where that leads us then. Okay, all right, what's the derivative of the top? A to the x. What's the derivative of the bottom? 2. Good. So we have e to the x over 2 Now we're ready to just evaluate and see where it takes us. Okay, so now we would have e to the 0 over 2. So what's the answer?
1/2.
1/2. So if you graphed that on your graphing calculator, you would find that the value of that limit is around 1/2. Okay, that's how that goes. All right, so you got to do L'Hopital's rule more than once sometimes. Okay, there's in some of my higher math classes, we do it several times. Okay, it can happen. Okay, the next one, let's go ahead and see what we have on this one then. Okay, so if you plug this in, you'd have 2 to the 3rd minus 3 times 2 to the 2nd plus 4. Kind of a pain to have to do this, but you do want to be careful about always checking this before you do L'Hopital's rule. Now you'd have 2 to the 4th minus 4 times 2 to the 3rd, 7 times 2 to the 2nd, 12 times 2 plus 12. Okay, and then this kind of thing you can just do on your calculator. Okay, like the numerator is 8 minus 3 times 4 plus 4. That's 0. And I'm just going to say I'm pretty sure the denominator is 10. Okay, you can work that out on your calculator. All right, all right. All right, I don't think I would have given you a problem if it wasn't that way. But occasionally on your homework, you may have something where you can't even use L'Hopital's rule. Okay? All right, so let's go ahead and do that then on this second part. So you want to go ahead and do L'Hopital's rule of the numerator. These are polynomials, so they should be pretty straightforward derivatives. So the numerator is 3x squared minus 6x. Okay, the denominator is 4x to the 3rd minus 12x to the 2nd plus 14x minus 12. Okay, like that. And if you plug it in, I think you still have a 0 over 0. I know that's going to happen. You have a 0 over 0 again. So we're going to go L'Hopital's rule a second time. Okay, so I want to do it again. Just go ahead and do your derivative of the top and bottom. Okay, sometimes you can do the arithmetic in your head to verify that it's 0 over 0. So now what we have looks like is 6x minus 6 all over 12x to the 2nd minus 24x plus 14 like that. And it's still 0 over 0. I mean, if you plugged in, hold on, no it didn't. I think we're...
Because 6 times 2 is 12, right?
Yeah, I think we're ready now to go ahead and evaluate this thing then, I think. Okay. Yeah, okay, so let's go ahead and plug in. So we have 6 times 2 minus 6, and then 12 times 2 to the 2nd, 24 times 2 plus 14. Okay, so the numerator on this one is going to be equal to 12 minus 6 or 6. I'll just use my calculator on the bottom here, so it looks like 12 times 4, 24 times 2 plus 14 is 14. And then that fraction you can divide by 2, so you get 3 over 7 is the value of that limit. Okay, all right. Okay, so when we got down to this, after we'd done L'Hopital's twice, it wasn't a 0 over 0 limit again. That's the reason I didn't do L'Hopital's rule. Does that make sense? So you have to be incredibly careful about that. Right here in the problem, that's not 0 over 0. If you plug the 2 in, right now you get 3 sevenths. Okay, so you're done. Okay, does that make sense? Okay, all right. Okay, let's work with a little bit of an infinity over infinity form again here. Okay, now on these problems, don't forget the way I taught you early in the semester. Can you guys tell me what the limit on this problem is? You're going to infinity. You can tell me if you remember the rules I taught you.
1 over 2.
3 over 6 or 1 over 2. Okay, I mean, you can do it that way. I mean, that's great. I'm teaching you L'Hopital's rule. The reason L'Hopital's rule is important is because that rule that I taught you works for a certain kind of function. It doesn't work for something like this next problem with LNs. Okay, so let's go ahead and just do this. If you look at this, this is an infinity over infinity form. So let's do L'Hopital's rule. Okay, so the numerator, you're going to have 12x to the third minus 2x. The denominator, you're going to have 24x to the third, like that. Now see, if you look at that, it's still 1/2. Okay, the degree of the top and bottom are still the same, so it's still 1/2. And it's still infinity over infinity again. So let's do L'Hopital's again, even though we know the answer. Okay, so let's see. The derivative of the numerator now is 36x squared minus 2. Denominator is 72x squared. And see, it's still 1/2. 36 over 72 is still 1/2. Okay, still infinity over infinity. Okay, so we can do the L'Hopital for the third time. Okay, we do that. We're going to have, let's see, that's 72x. Bottom is 144x. It's still 1/2. Okay, so I think all we got to do is just one more time and then we're done. Okay, so now we do L'Hopital's rule. So what's the derivative of top and bottom now? 72 over 144. Okay, now the limit of a constant is what? Just a constant. So the answer is 72 over 144, which reduces to 1/2. Don't forget this, the limit of a constant is the constant. Because if you graphed 72 over 144, all it is a horizontal line. And if you're going to infinity, it's going to remain at 1/2. It's not going to change. Okay, so I did L'Hopital's rule 4 times. Okay, all right. Okay, let's look at this next one here. Okay, if you plug in infinity, what will happen on this now is you have ln. Just think of if you plug in x, for all practical purposes, that's just ln of an infinite number. And what happens on an ln, it's helpful to understand something about a graph of an ln. I'm going to just put in my calculator, I'm going to graph ln of x. And I'm going to do this in a standard window because a lot of times students don't know what this graph looks like. So here's the graph of ln of x. See, it just gets bigger forever. It never levels off. It never does. It just kind of, it gets bigger at a slower rate. But if you put in ln of 1 billion, you would get a big number. So it just gets bigger forever. So that's going to infinity. The denominator is the same thing. For all practical purposes, this is really saying ln of an infinitely big number again. I don't know if that +1 is a part of the ln. I don't think it is. So it's really ln of infinity plus 1. So it's going to infinity. So you have an infinite numerator and denominator. Okay? All right? So know that. If you're doing ln of infinity, that's going to infinity. Okay, now what we're going to do is we're going to do L'Hopital's rule. And got to be on top of this. Okay, I was grading your tests. And starting over that yesterday, a lot of you didn't know how to do an ln. Okay, it's real easy to do a derivative of an ln. How do you do it? 1 over the function, then what? Times the derivative of that function. That's a chain rule. Okay, so it goes like this. So when you do the numerator, its derivative is going to go like this. 1 over 3x plus 5. So you remember, the derivative of ln x is 1 over x. But once you change that to ln of something else, then you got to do the chain rule. So the derivative of 3x plus 5 is going to be 3. So that's how that goes. Okay, now the bottom, what I'm doing on the bottom, now you got to be careful. See, the ln only belongs to 7x plus 3. So if you do that, what's the derivative of ln of 7x plus 3? 1 over 7x plus 3 times 7. Good. Okay. So 1 over 7x plus 3 times 7. And then technically you have that 1 there. Well, the derivative of 1 is 0. Okay, so you have this. Okay. Now we got what we call a complex fraction, so we're going to need to kind of clean this up and see how this goes. So let's write this numerator. See, that's 3 over 1, so it's really 3 over 3x plus 5 all over 7 over 7x plus 3. Okay, like that. Now, what you want to do is you want to simplify this. You wouldn't want to do L'Hopital's rule again, okay? Not in this form anyway. So remember, I'll kind of go to the side that what this is is this is really saying that you have a division problem. You're dividing two fractions. How do you divide fractions anyway? You flip the second one and you multiply straight across. So what you're doing is you have 3 over 3x plus 5 times 7x plus 3 over 7. Okay, so that's how you do that. Okay, so what we want to do next here is let's go ahead and multiply that out. Still got a limit as x goes to infinity. Now go ahead and just do like a distributive property of the top and bottom. Okay, so I'm going to distribute this. So I'm kind of working over here at the side of my paper. When I do a distributive property, I got 3 times 7 is 21x. 3 times 3 is 9. The bottom, I have 21x plus 35. Does everybody see algebraically what I'm doing there? Okay, got a complex fraction. That's a little algebra hang-up sometimes students have. Okay, do you know what the answer is from what I taught you early in the semester?
It's a constant.
Well, what's the answer to that limit? The degree of the top and bottom are the same, so what does that mean?
1.
Yeah, 21 over 21. Okay, now this is an infinity over infinity form, so if you plug infinity in, you get that. Let's go ahead and do L'Hopital's rule one more time. So if we do that, we're going to have the numerator's derivative is 21, the denominator's derivative is 21. So yeah, we end up with, the answer is just 21 over 21 is equal to 1. Okay, now see, without L'Hopital's rule, you wouldn't be able to do anything on that one. Okay, I mean, a lot of times students don't understand the point if I've already taught you an easy way. Well, if you don't know L'Hopital's rule, you couldn't do those rules on everything, because the rules I taught you don't apply to logarithms and exponentials. They're a certain kind of function like that. Okay? Okay, so let's go ahead and I'll give you a little time to do these problems. Okay, about maybe 5 minutes or so. And don't be lazy about the form, because you got to make sure that you have the right form before you start going to L'Hopital. I want to just sort of go through what I've got up here. Okay, so the first one's a 0 over 0 limit, and then really when you do the derivative of the top, you would get 2x. Derivative bottom is 1, so you end up with the limit of 2x, and you plug it in, you get -6. 2 times -3 is -6. Anybody have any question about that one? Okay, sometimes they're real simple. It all just depends on how complicated the derivatives are. Okay, the next one's 0 over 0. You plug in the -1, you're going to get that form. The derivative of the numerator is 1. Derivative of bottom is 2x minus 7. Okay, like that. So then what you're doing on that is you go ahead and plug in. Okay, now you can't do L'Hopital's rule again. If you did, you'd be messing up. You got to just plug in. So you got 1 over 2 times -1 minus 7. Work out the arithmetic. You're going to get -1/9. Okay, how's that look? Okay. Those are simple derivatives on the first two problems. They're not too bad. Number 3, when I was working it out, I could see, well, some students might have some issues with that one when they're doing the derivative of ln. Okay, so I want to review a couple of things on this. Okay, this one is a 0 over 0 limit, because if you plug 1 in, you have 1 minus 1 or 0. Then you really have ln of 1 to the 4th, which is ln of 1. If you don't know that, you put it in your calculator, you're going to get 0. Okay, basically ln of 1 means log base e of 1, so it's equal to 0 because e to the 0 is equal to 1, because of the exponential form. So when I did the derivative of the numerator, that's very simple, that's 1. Okay, but let me do the derivative of the bottom and explain that, because I think this was on your test you did and in some of your homework. Okay, the simplest way to do this is, what can you do with this 4? And bring it down. So you get 4 times ln of x. Now, if you do the derivative of this, if you're going to do the derivative of this, so you got a constant, write it down. What's the derivative of ln x? 1 over x. So that's 4 over x. Okay, so the derivative of ln x to the fourth is 4 over x. Okay, that's one way to do it. Okay, all right, then what I did is, see, this is a division problem. Here's the algebra that you want to make sure that you're on top of. See, right here I've got 1 divided by 4 over x. Well, how do you do that? You flip the second and you multiply, so you have 1 times x over 4. So that brings you down to this. So one of the things you'll get into in L'Hopital's rule is you're going to have to do some algebra from time to time, dividing fractions, stuff like that, simplifying stuff. Now you plug in and you're done. Okay, so it's no longer a 0 over 0 form, so just replace the x with 1 and you got your answer. Okay, hardest part of that for some students would be the derivative. Does that make sense? Okay, all right, and then number 4 is infinity over infinity. You have an infinite numerator. I said ln of infinity is always going to infinity, so you have that form. Okay, so the derivatives are easy on this one. The derivative of the top is 3x squared. Derivative of ln x is 1 over x. So again, you have this situation. With a little practice, you can do stuff like this in your head. You're doing 3x squared divided by 1 over x. So you do the reciprocal. 3x squared times x is 3x to the third. Okay, now the reason you get infinity for the answer is because if you plug it in now, you just have something that's going to infinity. Okay, like that. So the derivatives are pretty straightforward on that one, but you do have this algebraic simplification going from there to here. Does everybody understand that? You're going to deal with that on L'Hopital's rule a lot, where you end up with fractions that you're dividing. So do that at the side of your paper if you need to. Okay? All right, and then the last one is an infinity over infinity form. Derivative of the top is 2x. Derivative of bottom is e to the x. It's still infinity over infinity. Okay? So you do L'Hopital's rule a second time. Derivative of top is 2. Derivative of bottom is e to the x. Now plug in. So if you replace the x with infinity, notice you have 2 over e to the infinity, which is 2 over infinity, and that goes to 0. If you ever forget that, the thing is, it doesn't make any difference what the numerator is. If it's just a number, if you divide that by bigger and bigger numbers, I'll just do that. See, it's already close to 0. If you do 2 over 999, it's close to 0, but if that denominator gets bigger and bigger, it gets real close to 0. Does that make sense? Okay, so that's how you handle L'Hopital's rule for this section. Is there any questions about anything? Okay, and it's going to come in handy for different reasons. All right.